Awesome. So yeah, let's get started. It's 7 o'clock. So the topic today is domain-driven design. My name is Andy Maleh. I'm a senior full-stack engineer for a company called Eltropy. It's a company that builds conversational software for banks and credit unions, and I work in their debt collection department. So the key thing about today's talk is that it's mainly an invitation to read the book Domain-Driven Design, Tackling Complexity in the Heart of Software by Eric Evans. It's a very good book on doing practical software development in the real world of like business app development to solve real problems with object-oriented programming and design patterns and all sorts of different stuff. So before I go forward, who here has read the book or at least read part of it? Okay.
I took a course, an intro course.
Oh yeah, awesome.
I know the concepts of it.
Yeah, so the book came out in 2003, and I was working at a company in Chicago in 2006 that was a consulting company, and we discovered the book, so we did a book club on it in 2006, and we read the book over about 3 months, meeting every week, once a week, to discuss the book and read a half a chapter or a chapter every week. So yeah, after about 3 months of reading it, we actually took all the concepts that we learned from it and started applying them gradually on our Java app. We had two apps, a Java desktop app for salespeople that basically gave them software on their laptop. That was a desktop app to capture sales from their clients and record them on their laptop and then send them to the cloud to save all their sales data on the cloud after they've captured sales from their clients. So that was one app that we maintained. We maintained another app that was a J2EE app, meaning it was a Java Enterprise Edition application. It was using technology from the 2000s, like EJBs, EJBs was a big technology. Spring was a big technology. We used Struts originally, and then we switched to Spring. So anyways, that's how I came across this book. It took about 3 months to go through all of it, 3 or 4 months. It's a very big book. By the way, Eric Evans, the author of the book, offers a course for it, like a master class. And his master class is like two full days of education and learning to learn all the topics of the book. So that's about 14 hours of learning. So what I'm trying to say is I'm actually trying to distill all of it into 1 hour. So I won't be covering everything in the book. I'll be covering only the first few key concepts that I find the most applicable in my day-to-day job. The more advanced concepts are also applicable, but you can learn them on your own. So that's why I'm saying this is mainly an invitation to read the book. So today I'll be just giving you a very quick overview of the book, but I couldn't cover everything. There's no way I could. So what I'll be covering is an example business domain that I came up with to illustrate the concepts of the book that I'll be covering today. The first concept is business domain modeling. The second concept is the ubiquitous language. And the third one is the model-driven design. After that, I'll try to show you Ruby on Rails application code or examples of code, just to give you an idea of how to apply some of the concepts of the book. Again, I couldn't cover everything because the book is huge, but at least you'll get a glimpse of what you could do with the knowledge in Ruby. Topics that I won't cover are refactoring toward deeper insight, supple design, large-scale structure, bounded contexts, which is an idea that we were just discussing before the talk, which is, you were telling me that at your company you were trying to divide your business domain into multiple areas that don't have much overlap, and then you can divide the work between different teams. Yeah, and they do cover this topic in the book under bounded context, so I do recommend reading that when you have a chance. And the last thing is distillation. So these are the topics that I will not cover. They're very advanced topics that come later in the book, but at least you'll get a glimpse of the basics of the book, the first 3 topics. So let's start with the example business domain. So I'm gonna mention a music school business. I actually know how to play the drum kit. I play in a rock band in Montreal. I've been with Their name is Music Art. I've been with them for 3 years. But originally I learned drumming in Chicago about 12 years ago at a music school in Chicago that was called the Old Town School of Folk Music. They taught all kinds of different music, not just folk music. And they taught many different instruments like guitar, banjo, whatever. And they also taught drums. But they have a website that's a web application that lets you like enroll in classes. So yeah, they have different things on the website. They offer classes for playing music, singing, or dancing. They had also a music instrument store as part of their web application. So they had a completely different part of the app that was just a music store. They also had a part that was basically music events with famous musicians. So they would bring famous musicians, and they would, let's just say, a very famous banjo player called John Fitz was playing on, let's just say, whatever, July 2nd. So they would announce that on the website, and then people can enroll in that event and then go and watch that musician. So they also had that part of their web application. So they had a very interesting web application actually, and it was a very good application for applying domain-driven design because it had a lot of sophisticated features. And one other interesting bit of information about the website is they had multiple locations. So they didn't, the music school wasn't just one campus. They had like 3 campuses, if I remember right. So that was their website back in the day. That's how it looked like. But to show you, like the key areas are here: classes for learning how to play music, and then there's concerts, to attend concerts by famous musicians, and then there's the music store. Now there's also other areas like support, about us, basic stuff that you see on all other general websites, but these are the 3 key areas of their business. So let's start with the first topic that we'll be covering today, which is business domain modeling. So I would say that the 3 takeaways from that topic is that you want to start analyzing a business domain with knowledge crunching. So you want to acquire as much knowledge as you can about the business domain, and then crunch that knowledge and think about it and ask interesting questions about the business to learn more and more and more about their domain. So they call that knowledge crunching. So it's a very important practice to do knowledge crunching when you're learning about a new business or a new business domain. The next thing is continuous learning. You want to keep learning about the business domain as you're crunching, and you'll end up learning more and more stuff about the business, and then that will help you to get into deeper models. So first you'll come up with a general model of the domain, and then later you'll come up with a deeper model that has more details. So let's talk about knowledge crunching. So here's an example of knowledge crunching applied to this app. So if I were to go help as a software engineer on this app, and let's just say I'm like an architect, or I'm helping with the software analysis or domain analysis bit or requirements analysis, I will ask questions like this. I'll be like, what types of classes do you guys offer? Do you offer the same classes in all locations? Do you sell anything other than music instruments? These are all interesting questions because they're like, if it was only music instruments, I'd have only one model. It's just an instrument. And that's the model that would be the product on my website for everything. But if they sell other things, like let's just say they tell me we sell CDs as well, like music CDs, then now I have a different model. So like the website, I have to generalize the domain in a different way. Other questions are events paid or for free? Or like, do they have any free events, or are they all paid? How many classes does each instructor teach? Like for example, is it one instructor per class, or does an instructor have multiple classes? So that helps you figure out if it's a one-to-many relationship or a one-to-one relationship. So that's why that's a good question. How many lessons are in a class? So this helps you figure out, okay, is there a standard number of lessons in every class? Is every class, for example, a season where, like, let's just say if it's the spring season, then it's 3 months. So is every class 3 months? And that means it's about 3 months by 4 weeks, about 12 classes or 12 lessons? Or does it vary? That's an interesting question. Because if it doesn't vary, you can simplify the domain significantly and like write much simpler software. But if it does vary, then you have to take that into account in your domain modeling. And then another question is, do classes vary from session to session? So does every season, like spring, summer, fall, have the same exact classes repeating, or are there different classes in different seasons? So these are all different knowledge crunching questions that one has to ask in order to learn more about the domain. So that's one of the key concepts that were recommended in the domain-driven design book. The next concepts are continuous learning and deeper models. So continuous learning is like to learn more about what we just asked about. So we learned, okay, we have classes, we have concerts, and we have, so like 3 areas, classes, concerts, and what was the third one? A music store. So 3 areas, these are the 3 key areas of their business. But then you start learning more details about those areas. So like the instructors perform regularly at events. So apparently the events aren't just for musicians, even instructors perform at events, for example. That's an interesting bit of information to learn. So that would be you learning more about the domain model and making the model become deeper in knowledge about what they do. Instructors provide a series of classes. That's another interesting bit of information. So when I took like the drum kit class, they had drum kit 1 and drum kit 2. And if I remember, I've seen on their website, they had banjo 1, 2, and 3. So like they have series of classes that graduate students between different levels in every music instrument that they want to learn. So that's an interesting bit, because then you can connect classes in a series and build a new model called a class series to handle that. Another thing is certain events recur regularly. That's an interesting detail. So there are things that do recur. So I was asking earlier, okay, are there classes that repeat every season? Apparently, yes, there are classes that do repeat every season. So there are things that do recur. And then the music store offers location pickup service for anything that you order online. So you can order something and then go to a location and pick it up. So that's another interesting bit of detail. So this is more about like if you keep knowledge crunching, eventually you're going to learn more details that will add more depth to the model. So that's why you get deeper models. So originally you might come up with a very simple model that you implement first and release, but then later you learn more details and you start supporting more features with deeper models. So the book emphasizes that attention to detail is very important in business domain modeling. We cannot just generalize and assume something very simple and release it and tell the customer we don't like that's what you asked us for and we don't care about anything else. If we do that, customers will run away. They won't like what you build. So you do want to have attention to detail, ask interesting questions to figure out exactly what the customer needs are. So that's the first part of the domain-driven design knowledge that I'm covering today. Is just knowledge crunching, continuous learning, and deeper models. The next part is the ubiquitous language. So once you have a general idea of the business domain, one key concept that we thought was very interesting when I first read the book at a book club at my job back in 2006 is the idea of the ubiquitous language, because basically the key thing about it was that you want to try to come up with the business domain concept words that you come up with. You want to come up with words that are often used by the business people. You don't want to come up with words that only the software people use alone and that are different from what the words that the business people use are. If you do that, then you'll get into miscommunication or slowed down communication or slower productivity, and it'll actually affect you negatively in the long term. So one key thing is when we are coming up with the domain model, we want to model it out loud and verify every word that we use if it's the word that is used by the business people as well. So if for example, I can call the music, I can say music lessons or music classes, but which word is used on the website, or which word is the word that people commonly use at this school? If they use lessons, we want to use lessons too. If that's the word that the instructors like to use, we don't want to call it classes. If we call it classes, then every time we try to gather new knowledge about the system to implement it, we'll confuse the instructors when we tell them, okay, we're calling it classes and they call it lessons. So that's the key thing here is we want to model out loud and confirm that we're using the same words that the business people use. One team, one language. So we're going to use that same language among everybody on the team as well. So it's not like me in my part of the implementation, I call it class, but when somebody else implements it in their part of the software, they call it lesson. That's bad as well. Everybody on the team should use the same terms. Then we want to take advantage of documents and diagrams to help communication. And then there's something called executable bedrock, and then explanatory models. I'll cover those in a bit. So let's talk about model out loud. So here's an example. So I can, for example, write down some statements and just verify them with the business people. Say, okay, students enroll in a class with an instructor. Is this the right language or is it not the right language? They could correct me and tell me, no, don't say class, say lesson. So if they do say that, then I have to update it, correct it. Another example, students attend events. So I'll be like, is that what you guys call them, events? If they call them concerts instead of events, I need to note that. So these are all examples of how to start modeling things out loud. I can say, okay, customers buy music products. Maybe they call it something else. Maybe they'll be like, no, we call them music records and music instruments, but we don't call them products, for example. So we do need to take that into account. Instructors teach classes, locations offer classes, etc. So here are examples of what I was talking about. Course versus class, student versus customer, teacher versus instructor, event versus concert, location versus branch. We need to figure out what is the word that is most commonly used by the business people, and it's best to use that word in the software, not just in our language with the business people. Because the closer you make the business domain of the software to reality, the smaller the gap it is between code and reality, which improves maintainability of the code. And it improves communication as well. So the next thing is documents. I talked about how documents can help with documenting that ubiquitous language. So we can write down top-level goals for the system. So I mean, I mentioned in the beginning the three main goals of the system are selling music classes. The second one is hosting like concerts or events by musicians. And the third one was a music store, selling products in a music store. Whatever terms we end up deciding, I'm not using the right terms right now that they necessarily use, but we need to write down the high-level goals first. Next, we need to break them down into requirements. So we say, okay, like what is registering or enrolling in a class? What does it entail? What is it about? Like, what do I have to do? What kind of class is it? Is it a private class? Is it a public class? How many people are in the class? How much does it cost? Does the cost vary from teacher to teacher or instructor to instructor, etc.? So you need to write down all of those requirements. So that's the second level, breaking down the goals into requirements. And then the third level is taking the requirements and breaking them down into use cases. So use cases is when you're taking the requirements and making them software use cases that tell you what the user on the system is doing with those requirements. So for example, the customer enrolls in a class. That's a use case. Like, so the customer is the actor of the use case, and enrolling is like the behavior, the key behavior of the use case or the key goal. And they're enrolling in a class with an instructor. So we can flesh out the use case with more details, like, and break it down into steps. Say, okay, first you browse, you look up classes by instruments first, or categories. Let's just say instruments. That's usually how people want to take a music class. I want to learn the drum kit, so I will look up classes for a drum kit. If somebody else wants to learn the guitar, they'll look up guitar instrument classes. Next, they'll look up the instructors, and they'll read their bios. And then after that, they're going to look at the schedule of the instructors and then pick the class that fits their schedule the most. They might also check private versus public classes, and then finally they will pick the class that they like and they will enroll in it. And sometimes there's an element of payment as well. It depends. Like some music schools might have you register for a class, but then pay when you get there. Some other schools might have you pay online. So that's also an aspect of the system that we need to record. So that's what documentation is about. Next is the diagrams. So in general, like in software development, there are many different kinds of diagrams. If you're doing something at the database level, you would do an ERD diagram, like entity relationship diagram. If you're doing something at the object-oriented level, you do UML diagrams, like a class diagram, a sequence diagram, or a communication diagram. If you're doing, one key thing they emphasized in the book is not to get hung up on using very official diagrams. They're saying, okay, it's useful to know about UML, but don't get too caught up with like, okay, I have to do UML perfectly according to the specifications of a class diagram. Don't worry about that. Write any kind of diagram. So here we just have a mind map. This is a mind map diagram. It's just a bunch of, or it's kind of like an ERD as well. Like you have different entities and you have relationships between them. That's it. But if you write something, anything, they're saying diagram anything. Like build any diagram at first, just to highlight the general idea. And that improves communication significantly over not having a diagram. Then from there, you can flesh it out and pick the best diagram that would communicate the idea to other developers and to the business people. But don't get too hung up on how correct the diagramming is. Just do any diagram. Start that way, and then you can improve it as you go. So as you can see here, we have the key concepts. We have a customer, which can enroll in a class. So that's one of the goals of the system. The other goal is buying products from the music store. And then there's also events. So a performer can play at an event, or an instructor can play at an event, and an event is hosted at a location. This diagram is imperfect. Again, it's showing how it's imperfect. For example, I should have a connection from customer to event, which I'm missing. But don't worry about it. Start somewhere. That's the point. It starts somewhere, and then you can improve that diagram as you go. So this is not a perfect diagram, but it's intentionally demonstrating imperfect diagrams. They still give us a very good idea about the system. Like we have a session here, and classes belong to a session. A session could be a season, like a spring or summer or fall or winter. And then there could be a class series like Banjo 1, Banjo 2, Banjo 3. So that's pretty much it. That gave us a very good idea of overall of the entire system. That's what's great about diagrams. They say, a picture is worth 1,000 words. That's the benefit of diagrams. Next is executable bedrock and explanatory models. So executable bedrock is, everybody's familiar with this idea from elsewhere. This idea is popular in extreme programming. It's the idea of making the code document the domain. So in extreme programming, they advise against writing too much documentation. They say don't, like traditionally back in the old days of waterfall software processes in the 80s, people used to write huge like documents of requirement, specification, detailing every part of the software system before they implemented it. In extreme programming, they threw that away. They said, no, you only need like high-level documentation, like use cases or requirements or something at a very high level or goals. But and then you can take that and immediately write code that has the domain concepts in the code using the exact same terminology that the business people use. So if you so that way the domain knowledge is apparent in the code and the tests as well, also the tests. So you can write automated tests that document the domain that you're implementing. And that way class names will map that to the actual business model. So we will have a class name that's a customer, we'll have another one that's a class, we'll have one that's instructor. Basically every class name will map to one of the concepts that we just saw before. Method names will describe the behavior. So like enroll, for example, like a customer will enroll in a class, so there will be a method called enroll on class, for example. So methods should describe that, or enroll in a class, or purchase a product, or buy a product, etc., etc. The key thing here that's recommended in domain-driven design is strive for one model. So that's the key thing about the ubiquitous language, is we want to strive for one model in the implementation the design, and team communication. So like I said, like when we were, first we model things out loud and we write down some documentation. That's the design phase. And also that's the team communication phase in a way. We're communicating with the business people and between developers. So we use certain terminology there, and then we use it in the documentation and the diagrams, and then we use it in the implementation as well. So even the classes and the method names should also use the same terminology. So that's a very, very key thing that I learned from the domain-driven design book, which helped me at my job back in 2006 when I worked for a consulting company in Chicago. I was working in a team of about 12 people. We were able to simplify our system significantly by simplifying the terminology and not using words that diverge from what business people used. And that ended up making maintaining the software much simpler and much faster, much more productive. So that was a key learning for me, is that strive for unifying the words that you use. Don't like one day say class and the other day say lesson. Pick one and then settle on it, and then try to make everything use that word, whether it's the diagrams, the documents, the team communication, or the implementation, or the tests. So that's the second topic that I covered today in domain-driven design, which I find very practical. I do think about this every day in my job. The third topic is model-driven design. Model-driven design is basically starting to dig down into the code. So this is where we have to think about, okay, are we using an object-oriented paradigm? If we are, let's take advantage of that and build objects that map to real-world objects with the same names, with the same terminology. And then there's also the idea of mixing paradigms if needed. So for example, there are programming languages. When I was studying at McGill University for my computer science degree, I learned a language called Prolog, which was a logic language. It lets you write logic. It was only focused on logic, which is a part of algebra and math, if I remember right. And it was perfect for certain problems, like problems that are just logical problems. That was the perfect language for it. And then there's also, obviously, if you're doing something in calculus or like doing calculations, numerical computing with a lot of functions, then functional programming could be useful for that purpose. So what they're saying here is use the right tool for the job. And it's okay to mix paradigms. So you might have part of the system doing object-oriented programming for the key business domain modeling, but then certain parts that are very mathematical, like doing very mathematical computations, you could use functional programming there. And one nice thing about this talk being for Ruby on Rails is that Ruby is a multi-paradigm language. It does support functional programming and it does support object-oriented programming. So it's perfect for doing both. And they also said, okay, if you need even other paradigms like logic, the logic paradigm, or even a rule engine paradigm, you can also add those when needed. So it's just a thing to think about. We might not always do that. A lot of the time we might get away with just object-oriented programming, but there are times when it's useful to mix paradigms. Next, we want to think about layered architecture, and then there's associations between objects and then patterns. So let me dig into each one of those next. So I already covered this to an extent. So yeah, objects can generally embody any domain. We can always start with object-oriented programming first. But then certain domains can benefit from mixing paradigms like functional, logic, or rule engine. I already covered that. Next is layered architecture is recommended in domain-driven design. They said that systems are often built as a layered architecture. And it's true in Ruby on Rails too, because in Ruby on Rails, we have the web layer at the top, or the user interface, which is basically a web browser that lets the user communicate to a server in the cloud, and then that is the window into the server that enables the user to interact with the rest of the domain. So below that, there's the application layer, which is implementing the use cases of the app, like enrolling in a class, buying a product, listing products, etc. That's the application layer. The domain layer is the layer that is modeling the actual domain. So this is the layer that has the classes of customer, instructor, location, um, product, etc. Finally, infrastructure. The infrastructure layer is the layer that has lower level services like sending emails, sending SMS messages, writing data to the database, stuff like that. So yeah, I'm sure everybody's familiar with layered architecture. We all use a sort of a layered architecture when we build Ruby on Rails web applications. Domain-driven design, by the way, focuses mostly on the domain layer and to an extent the application layer as well. These are the two layers that it focuses on the most. So let's talk about associations. Associations is a big part of not just domain-driven design, but also Rails. Like Rails gives you many kinds of associations on active record. You can do one-to-one, one-to-many, many-to-many, etc. The reason why it's important to think about associations is because they say in the domain-driven design book that you want to try to simplify associations as much as possible, meaning if you can avoid bidirectional associations and choose unidirectional for certain cases, then that would enable you to simplify the code and only implement the unidirectional part and not implement the bidirectional. And also if you can simplify the multiplicity, for example, if you have a relationship between two domain models and you can start with one-to-many, but then later on you might discover that it's one-to-one. If you can come up with simplifications like that, it would also simplify your implementation. So try to think about the associations and come up with the simplest version possible of them. And that can be done with the diagram that I showed you earlier. So if we have an ERD diagram or a class diagram, and you have the associations, you can come up with the multiplicity. So I don't have it here written down, but you can write it down and say, okay, a customer can enroll in multiple classes, and also a class can have multiple customers. So this one is many-to-many, and unfortunately we cannot avoid that with this one. It has to be many-to-many. But product, however, can only be owned by one customer. So a product cannot be owned by multiple customers. So this one is simplified. A customer can buy multiple products, but each product is owned by one customer. So this one is a bit simpler. So yeah, thinking about all the different associations and trying to simplify them as much as possible is important to avoid implementing the most complicated version. Because obviously in Rails, if we want, we can use active record and make everything many-to-many association, but that would be insane. If we do that, like the system will become overcomplicated for no good reasons. So that's the key takeaway of this part of the book, is to focus on simplifying associations as much as possible. So that's pretty much it. Yeah, these are examples of associations often represent operations also. So like a customer is enrolling in classes. So enrollment. So it's the association is a form of an operation. It's good to think about the operations, not just the associations as one-to-many or many-to-many. Because there's the ERD version of association, which is like, one-to-many, many-to-many, one-to-one, etc. But there's also the object-oriented version of association, which is when two objects are associated with each other, the relationship usually is based on an operation. So a customer enrolls in a class. A customer buys a product. So yeah, buying, enrollment. For example, a performer, like a musician, performs at an event. So performing. Timing might be more about like scheduling related stuff. Location might be more about, you can have a feature that would locate people based on their web browser. Like you can find their location and offer them the best branch or the best location of the music school that they should register in, for example. So yeah, so these are all relationships that you could think about while you're thinking of associations as well. But one of the most interesting parts of the book is patterns and model-driven design. So they have patterns that are similar to design patterns from the Gang of Four, and they're also similar to grasp patterns, which I covered a few talks ago at Montreal.rb, at the talk that was titled Responsibility-Driven Design. So those patterns are a bit of in between the other kinds of patterns. So entities, they're basically there are entities, value objects, services, modules, aggregates, factories, and repositories. So let's jump into each one of them, see what they are. So entities are basically, they represent something that has an identity. So entities are any sort of concept or object that has an identity that's unique. For example, Thomas here is a unique person. He has an identity. He is Thomas. He's the only guy who's Thomas in this room. Even if somebody else looked similar to him, he would not be Thomas. Even if you had a twin brother, it would not be Thomas. It would be your twin brother would be a different person with a different identity. So that's what entities are. They represent unique things that have a unique identity. Another example of this is a car. If you have a car that's like a Mercedes S500 that's black, and your neighbor has a Mercedes that's S500 that's black, there's still two different cars. They're not the same car. And they have two different VIN numbers. So every car has a VIN number, which is like a vehicle identification number, and that identifies each vehicle uniquely. That way, for example, maybe David owns one of those Mercedes cars under a certain vehicle identification number, but then his neighbor has another car that's similar, but with a different vehicle identification number. So these are entities. Entities usually are unique and they're not interchangeable. Another attribute of entities is they're mutable, usually, meaning if you have a car, it moves, the location of the car is going to mutate. As you're driving the car, it's going to mutate the location of the car, so that's going to change. So attributes of the car could be mutated. You can mutate the radio station that's playing on the car. You could you could change the radio station from the jazz station to Chaume FM, the rock station in Montreal. Stuff like that. So they're usually mutable. Also, if it's a person, people age. So people have a date of birth and then they have an age and they age. Every year they're going to mutate into a different age. Like one year I'll be 41 years old, the next year I'll be 42 years old. So again, that's another example of mutability of entities. The third thing is they have a life cycle usually. They get created, updated, and destroyed. So I mean, you can build a car at a factory, drive it for a while, update it when you change the oil of the car or maintain it every once in a while. And then finally, when the car becomes too old and it gets impounded by the police or something, it gets destroyed eventually. So let's just say after an accident or something, they might impound it and it might be totaled and they might just destroy it. So usually entities have a life cycle. In Rails, typically entities are represented by active record instances. Active record instances. That's a key point. So when you build instances of active record objects, they represent entities because they have an ID. All active records by default, without changing any options, they have an ID, and the ID will identify every record as a different entity. If you ever outgrow the needs of active record, you can represent entities with active model if you want, or you can build your own Ruby classes and give them an ID. But if you're not storing them in a standard database, like the active record is mostly for relational databases. But if you're not using a relational database, you might have a different storage mechanism, or maybe you have objects that will live for a temporary period of time. For those cases, you wouldn't need active record. You could use Ruby classes or active model. So yeah, examples of entities here are customer, instructor, class. All of those are entities because they're unique. Okay, the next concept is value objects. So the next pattern. So value objects don't have an identity. They're the opposite to entities. They're basically identified by their values, and they're interchangeable. So one example of value objects is colors. So So colors, usually are represented, one way of representing colors is to use RGB, red, green, blue values. And you can, if you take a color that's 00255 for the RGB, so that's blue, and let's just say you instantiated a version of that object with 00255. Let's just say you destroyed it and you built another instance of that object with 00255. It is still the same exact value object because it's represented by the values that are in it. So the fact that it's 00255, it means it's the color blue. The color blue, you can build that object in your system 20,000 times if you want, but they're all the same. They're all the same exact thing. You can use any of them in your system and they would work. You don't need, they're not unique by identity. And they're not mutable, because the moment you mutate a value object, it becomes another value object. Like if I take the 255 and I change it to 128, it becomes a darker shade of blue. But if I do that, I generated a new value object that has a completely different color. So I didn't really mutate the original one. I actually just came up with another one. So value objects cannot be mutated. If you try to like they're usually immutable. You're supposed to make them immutable because it's confusing if you make them mutable. Because when you mutate them, they actually become other objects. So that's why usually they're not supposed to be mutable. And multiple instances are identical, like I mentioned. And they're usually handled by pure Ruby objects. So, I mean, who here can give me other examples of value objects?
Money.
Right, money. That's true. Because if you say you want the value of $5.20,
It's always $5.20.
it's always $5.20, no matter how you instantiate it. You had another answer. What was it?
Like a currency, like
Currency as well, right? Any other examples? There are simpler examples, like dates, like time, like strings, like numbers, like integers. They're all value objects. They're very simple ones. They're simpler ones. There are composite value objects like color, which is composed of RGB. There are simple ones like string, which is just one thing. Or I mean, string could be thought of as like a bunch of bytes that represent the string, but still, an integer is an even simpler one. It's just a number. So when you say the number 5 and you instantiate 5 in the system, it's always going to be the same 5. It's not going to change no matter how many times you instantiate it. Go ahead, you had a question?
Yeah. Correct me if I'm wrong. Our value objects kind of same like instead of saying it's a number that has a meaning, and that's the meaning is the value object. Let's say like
Yes. That is what the first point is. They're identified by their attribute values. Their attribute values identify the meaning of those value objects. So the key thing about value objects is that there's a reason why it's useful to think about them. I was working on a system in 2006 that was representing value objects as entities. And it was not so we learned the idea of value objects from reading this book, me and my team. And we're like, that's part of the system that we can refactor and turn it into value objects. So what are the benefits of value objects? Basically, I'm trying to remember what that part of the system was. Addresses, I think. I think it was addresses. Because addresses are identified by their street, city, and state, or whatever, or province. And if you take the same exact values and build the address twice, it's the same address. So the benefit of that is that they're cacheable. So you don't have to instantiate them multiple times in the system anymore. You can cache them once and reuse it many times, so that improves performance. So cacheability is a very useful feature in value objects. Also, you don't have to keep an ID on them. The fact that I don't have to keep an ID simplifies the code as well. Like you can simplify the software by not having, so if you build an active record for a value object and you want to store it in the database, you don't need to store an ID. You can tell it ID false in the migration. So that's one key attribute of value objects is when you build them in the database, don't give them an ID. Their values are the IDs. So that way you can cache them, you can, and you simplify the code. You don't have to worry about IDs anymore. And when you pass them across the network, you don't pass them with an ID as well. That was another thing we simplified. We were passing addresses across the network between two parts of our Java application, like two servers that were communicating over the network, and they were sending IDs, and like they had to reconcile those IDs from the source to the destination, and that was like wasting a lot of like performance and making code more complicated. And then we figured out, okay, we don't really need to do that. We just pass the value of the address, and that is the address. We don't need to pass an ID, and we don't need to reconcile it in the destination. The value is the address. So yeah, there are many simplification or maintainability benefits to using value objects. So examples here are cities are value objects, states are value objects. In this case, class names could be value objects if I want to use an instrument and repeat it across multiple classes. The instrument name is a value object in a sense. It's not mutable. It's just like, if I have drum kit, it's drum kit. I can use it everywhere, and it's drum. Or if it's guitar everywhere. So that is a value object. The session start date is a value object to an extent. Like the dates are a value objects. Okay. Next is aggregates. So aggregates are basically objects that are composite objects, the roots that are aggregating multiple entities. So in this case, we have a few examples of that. We have a class series, and it's aggregating multiple classes. So like I have a class series that's like the guitar series, and it's aggregating guitar 1, guitar 2, and guitar 3. So that the aggregate is the series, and it's composed of multiple smaller entities that are the classes. Another example to an extent is the instructor. The instructor could be an instructor that teaches multiple classes. Like an instructor has a schedule, and they might offer the class on Monday, Wednesday, and Friday. So they are an aggregate of multiple classes that are taught by that one instructor. So aggregates are basically root objects that connect to other objects that have associations to other entities. That's what they are. They're usually managing the life cycle of the other entities. So the aggregates are the ones responsible for managing stuff. For example, another example is a class is an aggregate of students, of customers. So like, let's just say there's a group guitar class. You can add to it, let's just say 15 students, 15 customers. They're all part of that class now. And the class is that the root aggregate that is taken, like that would be the source of truth about the class, not the customers. So you can add the customers to the class as entities underneath it. So that means the class is the aggregate, not the customers. Now in Rails, aggregates are simply just another type of active record instance, but they have associations of one-to-many or one-to-one or something like that. That's how they aggregate other objects through associations. And if you outgrow active record for some reason, or you don't need the database, you can just use basic Ruby objects for this. There's also, I wrote this down, but I'm not sure how common it is in real app development. So active record gives you hooks for the life cycle of an object, like creation, like you can say before validate, before save, after save, stuff like that. Rails gives you a feature. If you don't want to put all the logic inside the class, you can actually define external observers that hook into those events, and have each observer manage the create, the validate, the delete, after delete, stuff like that, or after destroy. But yeah, examples of aggregates is, I already mentioned some of them, like class series aggregates class. A customer can aggregate addresses, that makes sense, because a customer can have multiple addresses, like a billing address and a shipping address. And then a location aggregates, I'm not sure why location aggregates address. I think I'm wrong about that one. But and a location aggregates classes though. you could offer multiple classes at a location. So maybe that's what I meant to write. I'm sorry about that. Okay, the next topic is factories. So factories actually is available in the Gang of Four design patterns, which I covered a few talks ago. It's a common pattern for basically managing the creation of complicated objects. If you don't have a complicated object, you can just use the active record create method and create the object. You're done. But if you have to create, every time you create a class, you have to set up for it a location and set up an instructor and set up a whole bunch of other objects with the class, then that's a more complicated object. So you can create a factory. But in Rails, typically, so one interesting thing about Rails is factories could be added as factory methods on an active record class. So in Ruby, there's the active record instance, which is a specific customer, for example, or a specific instructor. But there's also the active record class, which gives you class level methods like find by, where, etc. to do active record querying. So create, stuff like that. So the class methods, you can actually, so there's the create, which comes with active record for free, but then you can add your own. You can say create, instead of calling it create on a class, you call it create private class. And this will automatically set up all the attributes for a private class that are unique to it. Like for example, the capacity of a private class is 1. There will be one person in it, not more than one. So if you want to have special factory methods, you can put them on the active record class, not the instance. You would put it as a class method. But another way of doing it, like the traditional way, is you would have a separate class that's a factory. There are times when that's useful. If you want to externalize the factory behavior from the active record into its own file that would manage the factory details. We've done this in my code base right now in my job, where we had a theme around, like for example, when we're importing debtors into our system, the theme is importing. And with importing, we have certain requirements. So we made an import factory that takes care of manufacturing objects for importing. And it sets everything on the objects that is needed for when they're getting imported into the system automatically for us, because the factory hides those details so that we don't have to worry about them. So instead of putting them on the active record, we created a class for that. So there are times when you want to create a factory class. That's the traditional way. But there are ways where you could take shortcuts and just make factory methods and add them as class methods on the active record class itself. I've done that as well. Another example of this is, like Rails gives you the feature of seeds. You can seed a lot of data, but also sometimes people like to make seeds testable. So what they do is they take seeds and they put them on a class. So the class is a factory, like seed factory, and that seed factory could be testable. You can write a test for it, seed factory test, and write a whole bunch of tests for it, and make sure it produces data in a certain way, and then you would have your Rails.rb call this factory class. So that's one way of taking advantage of factories. That's one example. So that way it can, every time it creates a music class, it sets up the location, the session, the instructor, and the class category automatically. The next pattern is repositories. So they handle storage and retrieval of aggregate roots. They manage lifecycle events like creation of objects, destruction of objects, stuff like that. Now in Rails, we do handle repositories usually with active record classes. So entities are handled with active record instances. Repositories handle active record are handled with active record classes. So the class itself is a repository because it gives you all the methods that you would expect from a repository, like find by class name, like you can put find by name, or you can build a query, say where name is this, instructor is this, location is that. And if you do that, then you're basically dealing with a repository, but you're dealing with it at the class level of an active record. And if you want, you can add your own repository methods as class methods on the active record class as well. So that's a common way of adding repository methods. So this is, in a way, a convenient way in Rails to, like in Rails, active record acts as both the entity and the repository. Now there are frameworks other than Rails, or even if you're writing your own code from scratch without using Rails, um, the DDD way of doing it, the domain-driven design way, is you would have a repository class that's managing talking to the database, and you would have an entity class that manages storing the data that you retrieve from the database and putting it on a model. And that's the model that has the business domain logic, like methods for calculating the total of an order or stuff like that. And I'm sure, Thomas, you've seen that in Hanami,
Exactly,
right?
exactly. It's exactly like this. The architecture is exactly like this. All the patterns in model-driven design, it is there.
Yeah, I believe Hanami intentionally tries to emulate domain-driven design as closely as possible. So they intentionally separate repositories from entities. So unlike Rails, where Active Record puts them both in the same file, in Hanami, you have a repository and then you have the model that gets produced by the repository. Now, in Rails, it's not practical for us to do it that way, unless there's a very good reason. In general, you don't want to do that. You just want to treat the class, the Ruby class, as the repository, and the Ruby instance or instance methods as the entity methods. So that's how we usually treat it. But if the file grows too large, though, that would be the time when you might want to consider having a repository class separately from the active record that manages complicated queries. So if you're just building basic queries, you don't need it. But if you need very complicated queries, where let's just say I give it the location of a school, like a music school, and it gives me all the classes. If I want to run a query like this, I'm sure you need to assemble the SQL part of it. You have to write a number of statements, but you can build one method that hides all that logic, and you just give it the location, and it gives you all the classes immediately. So that's a repository method. So you can build repository methods like that, and if you feel like the active record file is too large to handle that, you can just make a repository class that takes care of that. In Java, by the way, that was very common. In Java, we didn't have the benefit of, like, we didn't, I don't want to say benefit, but like in Java, it wasn't the same way as in Rails. We used Hibernate as an ORM, which is similar to Active Record, but Hibernate usually produced entities, and then we had a class that was the repository, and we put on it all the methods that did the querying. So we had different methods for retrieving the object for various attributes or arguments that you pass to it. So one of them is retrieving all the classes for a location. Another one is retrieving all the classes for an instructor. A third one is retrieving all the classes for a customer, etc. So it's good to know about it, but in Rails, we don't necessarily do things that way. Often you just use the class and do things in the class. But if you outgrow it, you do have the option of doing a Ruby class outside the active record that delegates some of its work to the active record. So yeah, you can have a student class that does the querying, or that has query methods as class methods, or you could have a student repository. You can have an instructor or an instructor repository, session or session repository. It's good to know about it, because knowing about it gives you options. I'm not saying necessarily you need this all the time. Like in my job, honestly, most of the time we do the repository querying in the active records as class methods. But every once in a while, we do actually build objects outside of active record that handle stuff. So it's good to have that option. The next pattern is services. Services is the pattern that is the last resort pattern. You don't want to build everything as a service. That's unfortunately a common anti-pattern in Rails nowadays, because a lot of people read blog posts about services and they use services for everything now, which ends up being a nightmare, because you end up with very, very tiny classes that have one method on each class, and you end up with like 200 files that you're maintaining. Instead of maintaining like 10 files, you maintain 200 files.
Hanami is like this as well, huh?
Really?
Yeah, it's each action is a dedicated file. So if you have many actions in a single domain, you're going to have lots of files. Huh?
Yeah, so in the Gang of Four design patterns, they have a name for this pattern. They call it the command pattern. Command pattern was not recommended for everything. It was only recommended if you needed fine-grained commands that you needed to execute in random order and be able to sequence them in any order you want, and also do undo, redo on them. So like you might execute 5 commands that do different things, and then you might undo some of them. So it's used often in desktop software or even on the web, like when you have a Google Documents, for example. If you're editing a document, every edit is a command that's executed, and then you can undo, and every time you undo a command that's in the stack. So they build a stack in memory of all the commands that you've executed. A command could be you typed something, or you executed a shortcut like Command V, or you did something else, etc. So, so one thing that's could be done to avoid this problem is to think about fine-grained services versus coarse-grained services. In Java, the way we personally did it when I learned the domain-driven design book is we didn't like to create 200 services, like a file for each service as one method. That was like that creates an explosion of files or classes that makes maintainability absolute hell. What we did instead is we grouped them by function. So if we had a whole bunch of things that are related to email delivery, then let's just say you can deliver an email as an admin that gets automatically sent from the admin from email address, or you can deliver an email as a customer, as an instructor. Pretend you are the instructor sending an email to a student, or you can send an email a third way from an administrator. Let's just say. So these are all email delivery services. If you need everything, if they're all related to the same function, you can just group them in one service. So you can make a class called email service, and it has 3 methods. So that way we have a class that's like 50 lines of code instead of 3 classes that have 5 lines of code each, which ends up being absolute hell if you have a lot of them. So we used to do that. We used to group services as coarse-grained services by function. We'd have an email service, SMS service, etc., etc. So that's one way of mitigating this problem. In Rails, by the way, so another use for services is also to represent use cases at the application layer. So there's the domain layer, and then there's the application layer that will orchestrate multiple domain models. So at the domain layer, I have an instructor and a class and a customer. But at the application layer, the customer wants to enroll in a class. The enroll in a class thing is actually a higher level operation that's at the application level. It's a use case, and you can represent that as a service method. And instead of building it as just one method on one class, you can make it something called the customer service, or the customer. Let's just say. Remember how we have 3 goals in the system? There's music classes, attending events like concerts, and the third thing was buying products. So you can divide it by those 3 functions. So we can basically have a service that is a class management service, let's just say. And it has most of the methods that are related to class management. So enrolling or canceling a class, etc., etc. So that's one way of managing complexity where you don't have to have an explosion of files. You would basically group files by functions.
But this is on the application layer, not on the domain.
Yes, this is at a layer above the domain.
Okay.
So we have a class enrollment service, for example, a music store service, and an event ticketing service for the 3 different goals of the system. And if we go back to the layered architecture, these are here at this layer. Because here at the domain layer, we have, class, customer, instructor, etc., like those active record entities, basically. But here you can have those services that have the use cases in them that operate a level higher. The key thing about those is they coordinate multiple objects from those. So enrolling in a class is going to involve the customer and the class, for example. 2 objects. So, but it's happening here at a higher level. Oh, and then the user interface, by the way. So to connect this to Rails, the user interface layer in Rails is basically the web layer. So here is the controller. So here you can have a Rails controller that is basically enrollment. Let's just say it's you have a classes controller, a music classes controller, and then the music classes controller can give you stuff that is basic CRUD, like create, read, update, delete. but you can add one more method to it that's a member method, call it enroll. And basically the enroll method on it will call the enrollment service or the management service. And it calls the enroll method on it. So instead of putting the logic on the controller, so yeah, one lesson or one takeaway of DDD for real Rails app development is often controllers and Rails end up being very complicated, and they mix details that are at different abstraction levels. The problem with controllers is that they're operating at the web level, so they deal with parameters, request parameters, session parameters, stuff like that, cookies sometimes, stuff like that is at the web layer. They don't deal with things at the business layer. If you have very simple business cases, people often put their code in the controller actions. But if you have complicated business cases, it's cleaner to do it this way. Instead of putting, you want to have the controller actions only take the parameters and convert them into what's expected of the services at the application layer, and then pass them here. And then the application layer works at the business level. So it doesn't think about request parameters and web stuff. It thinks about business stuff. It thinks, okay, I just have a customer and I have a class, and I want to enroll the customer in the class. And that's all it cares about. So that way your code becomes cleaner, because this code becomes focused only on translating web details into business details. And then this code is about translating use cases into things to do with domain models. And then finally, this layer will talk to the domain models, and then that's where the work happens in the end. So I'll show you an example of this. I'm sorry, the talk took a bit longer than expected, but I'll get to the code. We're almost done. I think we're pretty much done here. Yeah, services is the last pattern. So it's useful that you offload some of the stuff into service classes from controllers. That was the point I was just making. And these are examples. I just talked about them. Oh yeah, there's one more, sorry. There's one more pattern. Modules. So modules is a pattern that we're all familiar with from Ruby, because it's a fundamental part of Ruby. Ruby already supports modules. Modules is a way of namespacing classes in Ruby. So here they're recommending namespacing stuff. Like basically you want to divide your system into different modules that have different parts of the system. So like we have 3 parts in the system, 3 goals, key goals. There's the music store part, there's the class enrollment part, and there's the event ticketing part. So you can have 3 different modules and put in them the different models that are related to them. And sometimes the 3 of them might share some models as well. So there might be models that are shared across them, and there are models that are within each one of them. So I worked on a system in the past where we did that. After we extracted 3 modules from the system, we ended up splitting the Rails app into 3 different repositories, and then 3 different teams can maintain them separately. So I was talking to somebody earlier about the bounded context pattern from later in the book, which is about how to divide your domain in a way where you can divide your system to completely orthogonal parts of the system that could be handled separately by different teams. So this is a way of doing it. And in Rails, you can use Rails engines for this. So in that system, we used Rails engines. We had a Rails engine for one part of the app, a Rails engine for the second part. Like for one of them was for the music store, one of them was for the class enrollment, and one of them was for the event ticketing. And then we had a 4th engine that was called the common domain. The 4th engine was common domain classes that are used by all 3 of them, like customer. Customer is going to be needed by all 3 of them. So, but instructor is not needed by all 3 of them. Instructor is only related to maybe 1 or 2 of them. So either way, that's one way. So modules is a good way of dividing the system. I mean, it's useful to do. We already use, on my job, we already use modules in Ruby as namespaces for different parts of our app within the monolith, even without dividing it. But the nice thing about this is in the future, if we do decide to grow into multiple teams and divide the code into responsibilities for different teams, we can easily divide it after we've extracted things into modules. So it's very good to organize things across modules. So yeah, they're cohesive units of business behavior. They cut across software layers. Yeah, because they represent vertical slices that go all the way from the user interface to the database or services. And yeah, it's handled by Ruby modules or Rails engines. So let's talk about example one. Example one is an example. So I've actually given a version of this talk a long time ago at my job when I used to work at Groupon.com in Chicago. And I have an old example. It's not the best example, but I'm going to go over it first, and then I'll show you example two, which is real code that I wrote to try to mitigate the first example, like give a better example. But the first one is actually a bit closer to the Hanami way of doing things. So it's trying to do things by the book, the traditional way, not follow the Rails way. So it's basically, we have a music class model, but then we have the music class active record entity, and then we have a music class repository, and then we have a factory, and a class enrollment service. Now, this is just exaggerating the application of the principles of DDD just to illustrate them. It's not, I don't recommend doing this in real work. It's over-engineered, honestly. This is over-engineered, but it's just illustrating, okay, here's this service. This service is doing two things. It can handle two use cases: list classes for, a customer wants to see all the available classes, and then, and then enroll in a class. So it takes the customer in the class, and then it handles the enrollment. It delegates some of the work to the model, and it does some extra work here. It's pretending it's doing extra work, so it's just pseudocode. Here's the repository. The repository is doing repository things. This is kind of like the Hanami way, but basically this is handling everything that the active record class is supposed to handle. And the funny thing here is delegating everything to active record anyways, so it's not like I'm benefiting, but that's why I'm saying it's over-engineered. But it's just an exaggeration. It's just showing you the concepts from the traditional point of view. This is an active record that's just simulating, that represents an entity. And then this is a controller that delegates its work to the service. So like I said, the controller operates at the highest level, the user interface level, or the web level in Rails, and it's delegating the work to the services. Here, the create action is talking to multiple objects, like a repository and a service, but it's orchestrating multiple things. Honestly, I think it's better not to do that. It's better to have a service handle everything. So this is not the best example, but it's an example I used in my earlier version of this talk. I figured I'd keep it for now while I'm correcting it. But let me show you a real example I wrote on GitHub. So here's example two. So I built this app. I have it running here. There it is. Let me just zoom in. It's actually a scaffolded Rails app, like nothing special. It's only focusing on listing classes and then enrollment. And I'm actually logged in. So let me sign out just to show you that I'm logged in. So I'm logged in as John Doe. Let's just log in. And now I'm seeing all the classes. So session is 2025, Joel Epstein, Lincoln Park location, drum kit, description, level 1. Day is Monday. Then there's another class here that is level 2. Then there's level 3. Then if I scroll down, there's the private version of it. So this is the private version. It has a different price. It's more expensive. The capacity is 1 here, whereas here the capacity is 5. But I want to illustrate something here. If I go to the private version and I enroll in it, it's telling me class is full because I have another instance logged in here with a different user, Jane Doe, instead of John Doe. And Jane Doe already subscribed to that class. So capacity is 1, but enrollments is also 1 because she's already subscribed. And if I refresh it, you can see here, it says, it doesn't say enroll, it says cancel enrollment, meaning I'm already enrolled, and here it's showing enrollments is 1. So Jane Doe is already enrolled. Now if I cancel my enrollment, and I go back here, and I try to enroll now, it should work. Yeah, see, it worked. It said cancel enrollment, enrollments is 1. I got enrolled, basically. So this is just showing that the system is doing some bit of business domain logic in managing the domain and making sure that there's integrity to domain operations. And so let's dig into the code. Let's see how this works. So the key thing is that here's the controller, music classes controller. It just has an index operation that's listing all the classes. That's what we saw first. And then there's the show page, which is just showing one class at a time, which this is the page we're seeing now. So nothing special here. I mean, this is the page if you want to see it. The music class, this is it. It's just taking the music class and printing all the attributes, description, level, day, lesson count, duration, capacity, etc. But the key thing is here it's saying, okay, if I'm not enrolled, I can enroll. If I am enrolled, I can cancel enrollment. So those are linking into cancel enrollment and enroll actions. So if I go back to the controller, if I go to the routes in Rails, I basically have a music class. I added 2 member routes that are special, like routes related to the music class. So there's the enroll route and the cancel enrollment. You can add member or collection routes. These are member, meaning they're about one music class. They're not about the entire collection. So they're member. So that's meaning they affect one music class. So for one music class, I can enroll or cancel. So now if I go back here to the controller, there we go. I have an enroll method and a cancel. And if you look at the logic, it doesn't do all the work here. It's basically delegating everything to this music class enrollment service. It's giving it just the current customer that's logged in and the music class that is specified by ID, by Rails. And if it fails in enrolling, it's rescuing an exception and printing the message as a flash alert. That's what we saw when it said class is full, when I wasn't able to enroll. So basically this makes the controller very clean. Like the controller actions are super clean. They're not doing much. They're just taking the data, passing it to the service, and then redirecting. That's it. There's not much happening here. The real work is happening in the service. So let's look at the service. So we have an enroll method, and it's basically checking, okay, if the count of customers is less than the capacity, then we can enroll one more customer. If it's not, then raise an error if class is full. And here it's doing cancel enrollment. It's simply just deleting the customer from the customers. So this is showing you how the service operates at the level above the domains. It's doing things at a level above. Like these are use cases basically. And I'm handling errors with exceptions. That's one way of handling errors. A different way of handling errors is to use an active model and add validations and have the validations be the errors. I didn't do it that way. This is just that was just simpler for me to write it very quickly. But in a real app, sometimes you might want to do it with active model validations. We do that at my job sometimes. We do validations on active models. Sometimes, because you don't always need it. Sometimes you could do it on active record validations. Other times you could do it on active model validations. It's not always needed. But that's pretty much it. Another example of something that is useful, oh yeah, if we look at the music class itself, so these are the associations. That's the associations concept that I covered. So it has that one and belongs to many customers. So many to many between customers in class, but otherwise a class it belongs to a location, a session, and an instructor. And if we go to instructor, an instructor has many music classes. If we go to location, it has many music classes. If we go to a session, it has many music classes. So all of those are aggregates. But going back to the patterns, like this is the aggregate pattern. And also every one of those active records are also a form of entity as well. And then there is some business logic here. It's just checking if a customer is enrolled. So this is one way of adding business logic here. And then I actually use this business logic here in the view, and I check if the music class is enrolled for that current customer. If it is, then I show a different form. I show the cancel form. If it's not, then I show the enroll form. So anyways, nothing very special. It's a very small example, but it covers almost everything that I talked about. Do you guys have any questions?
Do you reckon that people are using it like full on in production, following all the rules from the book? Because like based on my experience, yeah, especially with Hanami, it is especially when you move from Rails, it feels like a massive overkill a lot.
Well, yeah, this is the key. The key thing about this is you need to apply it in shades of gray. You don't want to jump.
You cherry pick what you really need, but
Yeah,
when
you don't want to do everything all at once. That's why I said sometimes we use this. We don't always use it.
Unless the framework imposes on you, because this is the case here. Like
Yeah, and no, we don't use Hanami. We use Rails. So in our case, we don't. The framework doesn't impose anything. We could do whatever we want in Rails, but honestly, so here's the thing. I covered 3 topics today: business domain modeling, ubiquitous language, and model-driven design. Business domain modeling is something, yes, we do think about a lot, but fortunately, we have a person that's a product designer. He's the former CTO of my company. I say former because we got acquired by a larger company that has its own CTO now, so he doesn't do the job of a CTO anymore. He does a product design job now. But he can do all the knowledge crunching that I talked about earlier very, very well. So he does a very good job of it. And we do help him every once in a while. So what happens is we have grooming meetings for tickets or stories that we have to handle, like new requirements basically. And we have meetings for them about every week or every 2 weeks. And sometimes if he has unfinished ideas, he has us help him with crunching the knowledge of the new requirements. So we might ask him the questions that I was showing you earlier, like, okay, does the instructor teach multiple classes or does he teach one class? Does the instructor teach private classes only or public and group and private classes? So questions like that, we do help our product designer with that. So that part we always apply it, but it's not necessarily always the programmer, like the developers. Sometimes it's the product person that's doing the business domain modeling, but somebody at our company for sure is always doing this part. So this part, we definitely do it very closely to how domain-driven design works. The ubiquitous language is something I'm very, 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 what's the word I'm trying to look for? Like very, not strict, adamant about. I'm very adamant about it. I'm always trying to simplify words as much as possible and come up with the simplest word that matches the system. For example, one issue we ran into is we have some customers want to pay us in installments, and they call that a payment agreement plan. But at one point, we called it a payment arrangement plan. And then we have parts in our system that are calling it payment agreement and other parts that are calling it payment arrangement. So we have to take care of that and refactor it and come up with one thing. So that's a very good application of the ubiquitous language, is trying to come up with one term and then unify it in the system. That ends up simplifying maintainability a lot. So that part also we always apply it. We do write a lot of documents to document. I'm not talking about documents that are documenting stuff that the code is already documenting. Our code is self-documenting code and our tests as well, meaning we use the ubiquitous language in the code and the tests so that we don't have to write too much documentation. But we write higher level stuff like domain level documentation sometimes to explain concepts of what the customer wants to do with our system. So we do have documentation of that. We do have diagrams. Diagrams are very encouraged in my companies. We try for every initiative that we have, we try to come up with diagrams. So, and diagrams help a lot in understanding initiatives, especially when I go back into the past and I try to understand an old initiative, or when we hire a new developer and we explain it to him. When we show him diagrams, it helps a lot. So we do also, so yeah, definitely we cover the ubiquitous language part very, I would say, consistently. The model-driven design part is the part that I would apply in shades of gray. We don't apply this all the time. So the key thing about model-driven design is, if I go back into it, before the patterns, oops, here. So generally, we just use an object-oriented paradigm. Ruby lets you use functional programming simply from Ruby as well, like writing iterators that pass functions to functions, from iterators to other iterators. So we can do that in Ruby, so it's not a problem. We can use object-oriented programming or functional programming where needed. But generally, OOP is good enough. Layered architectures, yes, we do think about that all the time, and we follow layered architecture cleanly and correctly. And we do come up with classes that are higher level than the models every once in a while when there's too much logic that we don't want to put all in the active record. So that's a good idea to extract classes at a higher level that represent the use cases, but without creating a different service for every method. We don't do that, for sure. And then the associations, we do think about them and simplify them as much as we could. We avoid, for example, if I only need to add has many on, like a location has many classes, but I don't need to say, like for the class, well, I guess in this case, the class has to know its location. But there are cases where one of the sides doesn't care about the other. In those cases, we don't add the implementation for that side for the association. So we can simplify the code that way. So we do think about that. The only part that we do in shades of gray is patterns. Patterns for sure are only used when they're applicable. So entities are automatically applied in Rails with the active records, and repositories are automatically applied with active record classes. So this is instances and this is classes. So those are already there. Factories, we don't always do it. We do have a few factories in our system, but we don't always create factories. Every once in a while we create one. Aggregates happen automatically, again, as part of active records, so nothing special there. Services, we do it judiciously, like when needed, when we have use cases that have logic that cannot live in an active record, we create a class that handles that. Value objects, we try to think about them. One way of representing value objects in Rails that's useful that I didn't cover is enums. Enums often store value objects, like different values. And then modules, we do actually do modules. We do have namespaces in our system that divide our system by categories of application, or like what the customer is doing. So we do actually pay attention to the modules part. But I would say the modules part also has to be applied judiciously. In a new system, you don't care too much about modules, but once the system grows, then you care about dividing things by modules. So yeah, the answer is definitely shades of gray when applicable. Which is the right way of applying patterns in general. When I gave the previous talk about design patterns, and the talk before that on responsibility-driven design, in both of them I said patterns are applied only where needed. They're not always applied. They're only applied where applicable. So yeah, no over-engineering for sure. I'm a very big enemy of over-engineering. I don't like over-engineering, so that's one thing I keep in mind all the time in our system. So that's about it. Any questions? Go ahead.
About the business domain modeling.
Mm-hmm.
I'm curious about what type of activities do you do, what type of framework do you use in order to conduct a successful session when you do that?
We like to do sequence diagrams, like UML diagrams. The sequence part of UML diagrams or communication diagrams are helpful in coming up with the process of the system, like the steps of like. So yeah, we do come up with sequence diagrams frequently actually. So for example, let's just say recently we had a customer that needed to import stuff into our system via SFTP. So we came up with a sequence diagram that shows, okay, there's an SFTP server where the customer uploads a file, and then when that file gets uploaded, we have our server ends up picking up, checking that SFTP directory regularly, and then it picks up the file, and then it extracts data from it. So there's an extraction phase, and then after that there's an import phase, and then after the import phase, it generates a campaign automatically from the name of the file of the SFTP file that was sent to us. The name of the file follows a pattern that gives us some data about how to generate a collection campaign, because we're a debt collection. I work for the debt collection department of my company. So then there's the collection campaign generation, and finally we send the campaign. So to break the system down into all those steps, we do create a sequence diagram that has all the steps, and that helps all of us on the team, the developers, read that diagram and figure out the whole thing very quickly without it being too complicated to understand.
You don't need to go deep into the sequence diagram, just like really on the surface level, just in order to understand what we are talking about.
The highest level, yes. No, we don't document every little method in the software, because yes, there are pieces of software online that can take your code and convert it into a sequence diagram, and it documents every single method and what method it calls. We don't do that. That's too much for us. We do high level sequence diagrams that are just basically, we do it before we write the code actually. So that just gives us the high level overview of what's happening. and it gives everybody a good understanding of what the new feature that we need to implement is, and then we document it, and then we start implementing it.
So it's a document that you keep in order to further consultation, maybe.
Yes, we keep that stuff on Confluence, which is a form of a wiki.
Yeah.
So we do like to rely on Confluence quite a bit. For every initiative we have, we keep documents on Confluence, which could include diagrams, and often the diagrams, if needed, we include a sequence diagram. There are cases where the system is so simple that a sequence diagram is not needed. In that case, we might just create a class diagram or an architecture diagram. That's a very high level diagram. So yeah, these are the 3 diagrams that we use the most.
Thanks.
Go ahead.
I was gonna, I guess, provide a slightly different answer.
Oh yeah, sure. Go ahead. Sorry.
Where like DD is useful is like, especially if you're talking to like non-engineers, who often are like the source of truth for how the system should work. Doing the process of figuring out like how to model the business domain and like what words do they use, and like so like we like to think. I mean, at work, one of my colleagues like pushes us to really think about like what are the nouns and what are the verbs. So like, oh, I'm a class, I need to enroll. What does that mean in business terms? And like we like to focus like we don't have like up-to-date documentation. We tend to document changes instead. So we do have like an RFC process, which is pretty common. But like in your RFC, you would say, oh, I'm introducing like a new class entity. This is its attributes, and this is how like, this is its life cycle. So like I would create this is what I need. And like that vocabulary should be like high level enough that like someone who's not in engineering but who understands the business should be able to read this and confirm that like that is correct. And like if you keep it at that level, and you can have really sketchy diagrams, just like arrows and dots, just enough to explain how this works. Because then yeah, like the actual implementation, you can write it, we trust that you can write it, there's tests, whatever, but that becomes like the domain of engineering. But like agreeing on terminology and on like how like different pieces interact with the rules is like a useful part of DD.
And the terminology has to be reflected within the code.
Yeah, ideally, yeah. You want, because yeah, that's what Andy was saying. Like you want, if I call something, like I work in like the carbon credit space, I will never know what the correct term is. Like a lot of my work is like talking to people who are knowledgeable and saying like, okay, what would you call this? And like I'm just gonna use your word from now on, because then like every time there's a problem, what Andy was saying about like when you need to make a change later down the line, if I say like, oh, I called like your folder, like a you say folder IC directory, and I'm talking about directories, like we already have a communication barrier there, because like you're having to mentally translate into what I'm saying, or like the other way around. Because yeah, like our role in most of these like line of business apps is to model the business, and so that tends to be, unless like you have a naming conflict, which I don't know how you called your class, but that must have been fun in Ruby.
I called it music class.
But yeah, like
I definitely added another word because I cannot call it class in Ruby. It would conflict with class.
Yeah, unless there's like
class.
a technical reason you
right.
can't, like we try to keep the wording as close as possible, or like document why it's different, but like try to keep it as close as possible to what like our salespeople or like our business people call it, because ultimately like we need to be able to talk together to make sure that this is like correct.
It's a really cool exercise too. Like when you're trying to nail the wording, especially together, it's a great opportunity. Sometimes it exposes gaps of understanding as well. So you've been calling it this guy's been calling it this. Is this the same thing? If not, that's an area of research. We have to figure out what's going on here. So that's
exactly.
I've been really enjoying that.
Exactly. Yeah, because if they are different, then you've discovered a new part of the product that you need to implement. If they are the same, then you want to agree about which words you want to use going forward. Any other questions? Thanks a lot for the insights, David. That was very helpful. So yeah, again, as a quick review, all of those concepts come from the book of Domain-Driven Design by Eric Evans. This is an invitation for you to read it, so I give you a very quick overview of it. But the book is a large book that's highly recommended to read, and it does take, it did take me, in a book club, it did take me about 3 months at least to read it, or maybe 4 months. So don't stress yourself over reading it over like 2 weeks or something like that. It will take a while to cover it. Might take like a whole season, but it's worth it, totally worth it.
Do you think you
Especially if you do it as a book club. You could do it as a book club in your company with your team. And like every week you would have, like what we used to do is every week we would come up with a list of, each of us would come up with a list of questions, and when we compare notes, and we ask each other questions and we try to clarify topics. So we all learned it together much better, much more effectively that way.
and faster?
Mhm.
Because you're learning on one part, the other learns another part.
Exactly. Exactly. Do you have a question?
Me?
Oh, no. It's cool that you have a book club for nerds.
You know, I don't at my current company. That was at a previous company, but I've been trying to get something going. But hopefully we'll get it going in the future.
It is a dense book to start with.
No, we're probably going to do a different book first.
Like, I recommend,
We
like,
might do
the
Pragmatic
ones
Programmer,
like-
which is a great book as well.
Yeah, there are shorter ones because like this one and the like patterns of enterprise architecture. The, like,
Oh, that one is even deeper. Yeah.
Yeah, like those are very like information dense.
Right,
But, like, if you're
right.
doing like a book club, like maybe don't start with that.
Right. Right.
What was the name of the book?
So one's called Patterns of Enterprise Architecture. It's like a really thick black book by this guy
Book of
called
knowledge. Like.
Yeah, called by Martin Fowler.
Yeah.
Can't remember the other mention this.
Thanks.
Yeah, that's a good book too. That's a great book.
That one's kind of like this, but more of like the patterns basically. So like Martin Fowler worked with I can't remember what consulting company, but he basically
ThoughtWorks.
ThoughtWorks, yeah. And he spent his whole career being like, that's interesting. Let me write that down. And so like his books tend to be like a distillation of real world like experience and like patterns he's seen in the wild. So that and his like refactoring book are like excellent.
In fact, he came up with the idea of active record, which is what
Yeah.
Rails adopted. Like he wrote a book that had the active record pattern, and then eventually DHH read that book and copied that idea and applied it to Rails. So DHH didn't invent it actually, it was Martin Fowler if I'm not mistaken. Cool. So yeah, this is my contact info. I do have what I showed you in a repository on GitHub. So I'll post the slides on the Meetup webpage afterwards, but that's pretty much it. Thank you everybody for attending and asking questions.